Okay, so these notes are going to be about domain and range. The front is just basically some definitions and some clarification. So let's just go through this quickly here. It says domain is the set of all the possible values of the independent variable, which is usually x. If we have variables that are different from x and y, then it's whatever is in place of x. The range is going to be the set of all the possible values of the dependent variable, which is usually y, or f of x. So remember the other day we talked about that y and f of x. Those are the same thing. They're essentially interchangeable. Okay. All right, so we always write the domain or range and range from least to greatest. Domain again is the x, so we write it on from the x-axis. We go left to right, so on the x-axis we go left to right. On the y-axis, least to greatest is from bottom to top. So the y-axis goes up and down, so bottom would be least, the top would be greatest. Okay. Then it says discrete data or just points are written as a set. So for example, this is a set of discrete data. Discrete again is just points. So we have -1, 4, 0, 7, 1, 3, 8, -2. So the domain, this right here, D stands for domain. Domain is just the set of all of the x's. So if I mark all of the x's, that's a -1, a 0, a 1, and an 8, which is exactly how they're written here. So we write a set with these squiggly brackets like this, and again, we put them in order from least to greatest. Domain is usually already in order from least to greatest. That's just technically the way we write it. But if they're not in order when they're in the set, then you would have to write them like this. Okay. And then the range, so R stands for range, is just all of the y values. So if I mark all the y values, I'm going to use red this time. So my y's are 4, 7, 3, and -2. So all we do is we write them as a set. So again, R equals, and then with a squiggly bracket, range equals. But then we have to put them in order from least to greatest. So I can't just write 4, 7, 3, -2, because that's not in order. So I start with the least, so that's -2, and then next is 3, then 4, and then 7. So it is really important that you understand I cannot take a domain and range and make ordered pairs. I can take ordered pairs and make domain and range. With just this, I don't know if -2 goes with -1 or does -2 go with 1. I have no idea. So you cannot take a domain and range and put it into ordered pairs like this. Okay. All right, very similarly, continuous data, which is just a line or a smooth curve, we write as an inequality. So we have worked with inequalities a little bit, but we have not worked with inequalities like this. So this is different because we have our variable in the middle and we read it from the variable. So this right here says x, we start here, x is greater than or equal to, so when I read it from x is greater than or equal to -5, but less than or equal to 2. Or you could say and less than or equal to 2. So x is greater than or equal to -5, but less than or equal to 2. So what that means, I'll show you how we would get that. On our graph over here, we would find the least value for the x. So again, we're looking at the x-axis. So the least value for this circle, or that's actually an ellipse or oval there. The least value is over here at -5. It stops right there. So this is the lowest part of the x value. And then we find the highest, which is right here. So at this one, it's -5, and at this one, it's +2. So that's where this -5 and this +2 came from. We always put the least on the left, so least to greatest, and our symbols are actually always going to point this way because this would be least to greatest. So x is less than or equal to -5, x is greater than or equal to -5, but less than or equal to 2. So everything between -5 all the way up to 2, but not beyond that. It's equal to, we know it's equal to because it's actually touching right there. So it is touching at 2 and it is touching at -5. So same thing with the y's. So our range is y's. We start at the lowest and go to the highest. So our y-axis goes up and down. So we want to go as low as this oval or ellipse goes. So that's right here. It looks like that would be the lowest. So I would put a little mark here. And so that's at negative 1, 2, 3. So that's where that number came from, negative 3. And then it goes all the way up. Okay, my y-axis keeps going, but the actual graph doesn't go beyond this point right here. So this would be the highest y right there. So that is positive 1, 2, 3. So my y goes from, on the picture, again on the graph, from negative 3 here all the way up to 3, but not beyond that. So this says y is greater than or equal to negative 3, so above negative 3, but less than or equal to positive 3, so below that. So again, you want to think of it as above this, but below that. And the same thing on the x's. It was above negative 5, but less than 2. All right, so let's look at the next page. So it says, find the domain and range of each of the following and determine if it represents a function. So we did function last week, so hopefully you remember that. Again, a function is when x does not repeat. So looking at this set of data, my domain, again, domain stands for x. When it's a set, we're going to actually list it out. And we're going to write it as a set. So I'm going to do a squiggly bracket. I'm going to zoom in a little bit here. I'm going to do a squiggly bracket, maybe. And then I want to put all my x's. So these are my x's, negative 3, 9, 0, and 0. And I will put them in order from least to greatest. So the least of those is going to be negative 3. Comma, and then I'm going to put the next one would be 0, so not 9, but 0, comma, and then I have another 0. We do not repeat the value, so I've already put 0 one time, I don't put it again. And then the next number is going to be 9. So negative 3, 0, 9, and then I'm going to close that set with a squiggly bracket there. So my range is the same thing, except for we're looking at just the y's. So my y's are 4, 2, negative 1, and 0. So again, we're going to write those as a set. So squiggly bracket, we're going in order from least to greatest. So least would be negative 1. Then next would be 0. Next after that would be 2. And last would be 4. And then we close our bracket. And then the last piece there is it a function? So remember, again, a function is if x does not repeat. So if you look at your x's, we did have an x repeat, right? These zeros right here repeated, so this is not a function. So I'm going to just put no, it is not a function. All right, so looking at the mapping, same thing. What is the domain and what is the range? So these are discrete because they're specific points. So again, we're going to list out when they're discrete. So our domain is our x. So these are our x's. So I'm going to write them as a set. So squiggly bracket in order from least to greatest. This mapping, these are in order from least to greatest. So I can just write them like that. Negative 3, comma, negative 1, comma, 2, comma, 4. Close my bracket. Then the range, I'm going to do the same thing, except I'm looking at my y's this time. So these are my y's. I have 0. 4 is used twice, right? I have an arrow going to the 4 twice. We're only going to write it one time. And then 7. So these also happen to be in numerical order from least to greatest. So all I'm going to do is write 0, comma, 4. Again, 4 repeats, but we only put it one time. 7, close my bracket. Last part is it a function? So again, function is did any of the x's repeat? So I only have one arrow coming from each of these x's. So the negative 3 was used once for the negative 1, once for the 2, once for the 4. So this is a function. So I'm going to put yes, this is a function. All right. So looking at the graph, same thing. These are also discrete. We have specific points. So this is a discrete set of values. So we can just list them out. So there's a couple of ways you could do this. You could write out each ordered pair, and some people might need to do that. Or you could just look at the graph and count kind of as you go. So domain is x, again, so we're looking at our x's. So I just need to figure out what is this x right here, then what is this x, then this one, then these two right here, they have the same x, right? So if I can list them out, or I can just count as I go. Domain is least to greatest, so we want to go left to right. So I'm going to start with this one right here. So my domain here, I'm going to use a squiggly bracket because it's a set. So my domain, I'm going to count to -1 to -3. This is -3, the x is, comma. Then the next one going towards the right, from left to right, the next one is right here. So that x is -1, 2. So -2, comma. Then again, moving to the right, because we're getting greater, my next one is right here. So this is at +1 on the x-axis. So 1, comma. And then both of these are the same x value, so we're only going to put one of them. They're both at 1, 2, 3, right? X is 3 right here. So 3, and then close with a bracket. All right, so range, same thing, except for range is the y values. So on the y-axis, from least to greatest, we go bottom. So start down here at the bottom, and we're going to go up. So we're going to start with this one down here at the bottom, then we're going to move to the next one, then to this one, then this one, then this one. So the y value here, again, y, we count down, so -1, 2, 3. So this is -3. So bracket, -3, comma. Then this one is at -1, 2. So the y here is -2, comma. Then the y here, right here, y is 0. You don't have it moved up or down. So the y here is 0, comma. The y at this one would be next. We go up 1, 2. So the y here is 2, comma. And then the last one is right here. So up 1, 2, 3. So 3, close your bracket. And then it asks if it was a function, so hopefully you already know that this is not a function. So I'm going to put no, and then we'll talk about why, just in case you don't know. So no, it is not a function, and that is because this point right here and this point right here have the same x value, right? This x right here at 1, 2, 3 is cheating with this one and this one. So x is cheating here and x is cheating here. So that is not a function. It does not pass. Remember, we call it the vertical line test. So if I drew a vertical line through this point, it also goes through that point. So it does not pass the vertical line test. All right, so looking at the graph, now we have a continuous set of data. So we have a point here and we have a point here, but we have all of this stuff in between, and there's no way we could list out every single point on this line from here to here. So this is why we write a continuous. So if it's connected by a line or a curve, we write it as an inequality because it's everything from here to here, all the decimals and fractions in between. So that's why we write it as an inequality. So domain is going to be x, so we're going to put x in the middle. Remember, our symbols are always going to be pointing this way, and then we have to decide if it's equal to. So I don't know yet if this is going to be equal to or not. So the way I know that is if this dot is filled in or if it's touching right there, it is equal to. So in this case, that one is equal to. That's on the left side, so it's equal to. The one on the right side is also filled in, so this one is going to be equal to as well. And now I need to know what is the lowest domain, what is the highest domain. So again, domain is left to right. So on my x, I'm going to go all the way to the left, this graph. While the graph keeps going, the actual line does not. It stops right here. So my lowest x is right here at -1, 2, 3. So this is at -3. So I'm going to put -3 on this side. And then the highest going to the right, so I go to the right, is right here. So again, the graph, the grid goes, but this line actually stops right here. So this is going to stop right here at, that's 1, right? We went 1 to the right. So the highest value for the x-axis is going to be 1. So the highest value of the domain is 1. So x is greater than or equal to -3. So everything from -3 up to 1. All right, so looking at the range, same thing, except for range is y. So we're going to put a y in the middle. All right, we have a starting point down here and an ending point up here. So we're going to put our symbols like this. Again, we need to know, are they equal to or is it just less than? So at this point, we see that this point is filled in and this point is filled in. Maybe you can see that. I'll erase that just in case so that way you can see that that was filled in. All right, so there it is, all clean. So now we have a lowest point here for our y. So lowest it goes. Whoops. So here, so that's where y is 1 because we went up 1. And then we go all the way up to, this is 1, 2, 3, 4. 4 right here. So the highest y here is 4. And those, again, are touching. That's why I erased it. So from 1 up to 4 and everything in between, but not beyond that. So from 1 to 4. So y is greater than or equal to 1. Right here, y is greater than or equal to 1, but less than or equal to 4. Last piece is it a function? And hopefully you know already that yes, this is a function. No x value repeats. I could draw a vertical line through this every single place and it would only touch one time. All right, last one. This one's going to be a little bit different. So the domain here, we are looking at the x-axis, right? So what I see is that on the left side, right, if I'm going from least to greatest, I have arrows here and I have arrows here. That means it's going to keep going forever, both up this way, but also out to the left. And this one is going to keep going down, but also out to the left. So my x's are going to keep going forever and ever and ever. And we call that to infinity. But they don't go higher than this x value right here at 2. So this one I kind of have a starting point, but I don't really have an ending point. So when that is the case, it's not like this where I have two clear ends. I'm going to write an inequality, but it's not going to look like this. It's going to be just the variable with one symbol. So I'll show you what that looks like. It's going to be x, right? Domain is x. And x is everything from this point right here at 1, 2, right, on the x-axis, and less, right, to the left. So x is going to be less than or equal to, because it's touching right here at 2, less than or equal to 2. Everything less than or equal to 2, and it's going to keep going on and on forever to infinity, or to negative infinity, actually. So the range is similar, except, right, it's going to keep going down. So the y values are going to keep going down, and it's going to keep going up. So it's going to go everywhere from negative infinity way down here at the bottom, which we can never get to, all the way up to positive infinity. So the range in this case is everything. All real numbers is how we're going to write that. So I'm going to write out all real numbers. So you'll see that a couple of different ways, but today we're just going to write all real numbers. And then lastly, it wants to know, is this a function? So we did this example last week. Hopefully you remember. Again, if it does not pass the vertical line test, so that means when I draw a vertical line, it should not cross more than one time. And you see right there, it crosses there and there. So that does not pass the vertical line test. So this x and this x, those are cheating, right? So this is not a function. So no, it is not a function.